Okay, I'm going to have a quick look at the Maths Methods Paper 2, Tech Active. I've had a couple of requests to go through this one, so I'll get through as many as I can in the time I've got today. So starting off with question 1, I have done the multi-choice in a previous video if you want to check that out. Unfortunately can't post the links in the comment section anymore. YouTube's changed that feature, but if you want to check it out, go to the playlist of external exam papers and the multi-choice one is there. So first question that we have in this paper is a fairly straightforward one and an interesting one to include in the Tech Active one because it doesn't require a lot of calculator work. So we've got a salesperson has a 20% probability of making a sale to each customer who enters the store. Each sale is independent of all the others. Determine the mean number of sales on the day when 25 customers enter the store. Pretty standard question. I feel like even most junior students would be able to have a go at that, knowing their expected value, because that's pretty much all you're doing. So you're just doing your 25 times your 0.2 and getting 5. So that could even, I feel, have made it into a tech-free question. Determine the standard deviation of the number of sales on a day where 25 customers enter the store. Your standard deviation is your square root of your NP outside of one take P, or old school we had NPQ, where we had Q was the probability of failure as opposed to success. So we've got square root of 25 times 0.2 times 0.5, that should be 0.8 there. Because 1 take 0.2 is 0.8, which gives you the 2 there when you work that one out. And then we've got, now we get into a bit more of the actual calculator concepts. So we've got the determine the minimum number of customers that who would have to enter the store to have an 88% chance of making at least one sale. So this one takes a little bit more, so we've got 3 marks allocated here. At least one sale, scoot that up. At least one sale means it's not 0. So that's important for being able to solve for that NCR or the combinations part of it for your binomial. Obviously, if you don't know the number, you can only find the 0 or the 1. 1 being, it would be the n value, solving for that. So for this question, if we have not 0, then we can do 1 minus the probability of 0, and the 0 is something we can find out because the n0 value is always going to be 1, no matter what the n value is, because if we go to our Pascal's triangle to the side here, you can see that that n column is 1. So no matter what number of trials you have, if you've got 0 successes or all successes, you're going to have that 1. So that's basically the combinations you can do. Or if you've got that second one, it's the n value there. And so sometimes you can be given that to work out. Back to the actual question. So we've obviously got no sales, so our chance of success is raised to a 0. Our chance of failure or not success is raised to the value of n. So then we get to a point where we have 0.88 is equal 1 minus 0.8 to the power of n. So then we want to take the 1 over to the other side. We're going to get the negative. So we can say that 0.12 is equal to 0.8 to the power of n. You can solve that with your logs, or you could also just pop it in your calculator. So in the QCAA solutions, they've got this log solving. The other option is if you put that into the y equals 0.2, y equals 0.8, and just find the intersection using your second trace is another option there. And because you get 9.5019, you want to know to at least one sale, like the minimum number, you round up to the 10 for that because you want it to be get at least that amount. Then question 12, we've got, suppose that the distance travelled by vehicles within a year can be modelled by a normal distribution. So there's the key info there, normal. 2021, we've got a mean of 13,700, standard deviation of 3,400. Determine the probability of the vehicle chosen at random travelled less than 12,000 kilometres. So this is just a really standard one using your calculator. So we've got our second vase. I'm using my TA84 plus CE, of course. I'm putting in, so I want from 0, and the upper will be the 12,000 because I want less than 12,000. So that's that bottom section here between 0 and 12,000. And then my mean is, what have we got up here? Mean of 13,700, pop that in. And my standard deviation is 3,400. So popping that in there, and we get 0.3085. And so when I looked at the marking scheme, this diagram explanation is actually part of the mark. So making sure if you've got a 2-mark question and it is just a straight calculated question, make sure you are giving an explanation of why you did that and how you got your answer. For the second part, determine the value of X, where 60% of the vehicles travel less than X kilometres in 2021. So I've got my little picture here. If it's 60%, I know the mean is where the 50% is, so it's above that mean there. That also helps me when I get my answer to make sure it's a reasonable one there. Because I'm working backwards from a probability, I'm using my inverse norm. And so do my second vase, my inverse norm's there on 3. My area is 0.6. My mean is the 13,700. My standard deviation is the 3,400. And then I'm telling it which side. So I want the left-hand side there. And these calculators are great compared to what we used to have, which was nothing. And the previous versions of that, when we only had the T83s, you could only do left. So if you wanted the right side, you would have to do 1 minus. These ones you can choose. You can even choose center. But in this case, we've got our left. So we can do that one. And we get an answer of 14,561.38. And remember to include your kilometres. Okay, that was 12, so on to 13. We've got a little trig one solving for A and B. So a few little tricks in here. They've made it a little bit more interesting by saying since 6 a.m. is your time. So you just have to remember each of the times that they're giving you. So the 8 meters here, that's going to be 2 hours since 6 a.m. Oh, sorry, yeah, because it was 8 a.m. At 5 p.m., obviously that's going to be 11 hours since 6 a.m. So we can set up, there's our 2 coordinates we can use there. We're solving, and so we get our, when we're popping it into our rule, we've got 8 equals A plus B sine of pi on 6 times 2 minus pi on 3. That's going to give us 0 when we work that out. So sine 0 is 0, so we can get that A is equal to 8. Then we can use that in the second one to solve for our B by subbing in those values there. That gives us the B equals 5, which we can then put into our rule. So that was part A. Part B, it's only 2 marks. So in light of that, we've got determine the rate of change of the width of the beach at 8 a.m. So I thought that probably the easiest way to do that is to pop that equation rather than doing my derivative. Just pop this into my y equals, and I can then use that second trace 6, the derivative part, and put in the x equals 2 to find that derivative out there. Then I can just look at the graph and see where else it looks, where that's cycling, and because it appears to have that 12-hour cycle, I know the next time is going to be 12 hours later, which is 8 p.m. Had it been worth a few more marks, I probably would have wanted to do a bit more algebra involved with that, but being 2 marks, being tech active, I'm making use of my calculator there and trying to get through the questions. For question 14, so here we've got another sampling one, another one with our n value, but this time we're looking at our confidence interval. So this one, I've seen a lot of confidence interval ones over the past papers, so definitely something to know how to use, definitely to know this 1.96 value for the 95% confidence interval, and make sure you know that. So we've got randomly sampled 200 different pet owners, found that 50 celebrate their pet's birthday, so that gives us our p hat of 50 divided by 200, which is 0.25. Our n is 200, and so to get that confidence interval, we're doing our mean, or our p hat, plus or minus the 1.96, square root of p. This is on your formula sheet. And so we're popping that in, and we get the 0.06 that we're going to add and subtract from our mean. So we get these values over here of 0.19 and 0.31. When we get to the second part, this one did I wasn't reading carefully and forgot names and what we were doing here. So I did start this off and do it just based on these two here, and then realised I needed to include the Ravi from the start. I wasn't paying attention properly. So just be careful when you're reading it, not assume this info is the same as what's up the top here. So when I first read it, I just did it for the 250, not realising I had the 200 as well from the top. So that means my sample then becomes 450 from the 200 from the original plus the 250 from that table. My p-hat then is going to be my 50 from the original plus the 26 plus the 34 over 450, which gives me 0.244. Probably easier to leave that in fractional form. I just left the decimal on my calculator. And then I'm going to do that same operation that I did up in part A, the 1.96 times the p-hat outside of 1 minus p-hat. And I've got my decimals squished in there over 450 because I had to come back and change it, which gave me the 0.2047 and the 0.2842. Then that still carries on. 14. Felt like there was a... There we go, still over here. So it then goes on to part C and wants you to use your results from A and B to evaluate the reasonableness of the suggestion. So when you look at that, obviously the more you sample, the more accurate or the better estimate you're going to get. So when the sample size is bigger, you get a better estimate, plus your confidence interval is reduced. So you've got a smaller number that your confidence interval is between. Then we've got, and part D of that question just keeps on going. The proportion of all pet owners who celebrate their birthday is 0.24. So now we're given that information. We're going to use the normal approximation to determine the probability that in a randomly selected sample size of 200, more than 30% of the owners celebrate their pet's birthday. So we need the standard deviation to start with. So we're using that 200, we're using the 0.24, and we get the 0.302. I started going down one track where I converted them all to the numbers rather than the decimals. So the 0.3, the 30%, changing that to a number, but then I went, no, I'm going to go with my original so my lower limit, so more than 30%, I'm putting in as 0.3. My upper, because the maximum you can get for a percent is 100%, so that is 1 as a decimal. My mean is 0.24, and my standard deviation is 0.0302. So just keeping consistent with what type you're using for each of those values that you're inputting. And then that gives you 0.02347, just rounded to 0.0235 for that one. On to question 15. Now this one was a fairly messy one with a lot of different angles in it. In hindsight, probably using a ruler might have helped me out there, and gotten a neater diagram. So we've got the hiker beginning the journey, walking for 8 kilometres on a bearing of 52. She then walks on a bearing of 210 in a straight line. So I started out with a bit of a rough diagram, which I then transferred into my triangle. I also did a bit of working out here to show I've got my 210. I also know, based on my U rule here, that if I've got 52 there, that one's 128, which then allowed me to work out this top angle here of 22. So I put that on my diagram over there. That allowed me then to find that distance of x. Now, I want to determine the direction, but I kind of need the x to be able to then solve for that angle. The other thing that I did, and it was a little bit different to how the work solution set it out, was I went and solved for that 30 based on my little triangle that I've got going over here, where I had my worked out a few different angles based on the 210, then the leftover part of 30 from the straight line, and then that part being 30, making that little right angle, finding the 60 down there, and then finding the 120. The 30 was the bit that I actually ended up using a bit of a Z rule to use that when I was then working out this part here that I needed to use to get the bearing. So I took that away once I'd found out that angle. The other trick they put in was an ambiguous case, as if they didn't need to make it, as if it had to be any harder. They gave you an ambiguous case. Obviously, when we're looking at this angle here, it definitely looks obtuse. So we disregard the 53 and use the 126. I then took that 30 off for this part of the diagram up here to find this part. And then because I'm going from north around, I did the 360, take away that 96 that was there. So that gave me the 263 for the bearing. As I said, the work solutions that QCAA put out do it slightly differently to work out that bearing than I did it, but that was kind of what made sense to me when I was doing it. And that is where I left it, where I was up to time-wise. So if I finish off the rest, I will also load for question 16 and onwards. Hopefully that helps you out with your study this weekend, and good luck for Monday.